Find the following indefinite integrals. First indefinite integral, just to warm up, e to the minus 3x plus 4 dx. So what I have here is e to the u, and u is equal to minus 3x plus 4. So we have a u substitution. Okay, the minus 3x 4 is the inside. So u equals minus 3x plus 4. du equals the derivative of this times dx, so that's minus 3. And then I have dx equals du over minus 3. So I'm going to substitute in for u and for dx. So we see we get e to the u, and then dx becomes du over minus 3. Minus 3 comes out in front as a minus 1/3. Antiderivative of e to the u. Okay, this is great. The antiderivative of e to the u is just e to the u plus a constant. So I get my answer, I put back in for u, and we wind up here. Now I should check this. So what's the rule for the derivative of e to the u? That's going to be return e to the u, and then multiply by the derivative of u with respect to x. So here, we're just going to return e to the u, and then I'm going to multiply by the derivative of the top, which is just minus 3. So the minus 3 and the minus 1/3 cancel out, leaving me with just e to the minus 3x plus 4. And that's going to give me what we had when we started out. So this checks out. For our next one, let's consider e to the x minus 2, e to the x minus 3 over e to the x dx. Okay, the first method we could try, which is probably more straightforward, just want to expand the top. You're going to divide e to the x into each term, and then you're just going to do a substitution, take the antiderivative. You'll have to divide by e to the x again when you do that. What we could do instead is, I want to call u equal to e to the x and just substitute in right away, and then we could just work with polynomials and forget about e to the x. So du equals e to the x dx. dx is equal to du over e to the x. So I'm going to substitute in for the ones in top. I have u minus 2, u minus 3. Our du is just going to, dx is going to become du over e to the x, and I have my other e to the x, which I probably should have called u at this point, but that's fine. And we notice we have 2 e to the x's in the bottom, but we can get rid of them with our substitution u equal to e to the x. So this thing goes entirely in terms of u. Okay, I expand the top now, and I divide u squared into each term, leaving me with this. And we put our exponents up as minus signs, because that way it'll be easier to take any derivatives. So 1 minus 5u to the minus 1, plus 6u to the minus 2 du. We do any derivatives. So the 1 turns into a u. My 5u to the minus 1, well, that's 1 over u, so that turns into natural log of absolute value of u. And then for the last one, we add 1 and flip it over. Adding 1 makes it a minus 1. Flipping it over just puts a minus sign out in front. I substitute back in for u, so it's going to be e to the x, minus 6 e to the minus x, and then in the middle I have minus 5 natural log absolute value of e to the x. Okay, the absolute value of e to the x is just e to the x. E to anything is a positive number, so the absolute value doesn't do anything. There's no way a negative can show up, so I'm allowed to drop that. So that'll be natural log of e to the x, and then that's going to collapse to plain old x. So my final answer, e to the x minus 5x minus 6 e to the minus x plus c. We can check. Let's take the derivative of this. Derivative of e to the x is just e to the x. Derivative of minus 5x is just minus 5. Then derivative of minus 6 e to the minus x. Well, that's e to the minus x times the derivative of the top, which is just the minus 1. So that takes away the minus sign. Leaves me with this. And if you expand out our original integrand, you're going to see that these two things, now these two things are the same. For my final integral, let's try e to the x dx over 1 plus 2 e to the x. Okay, you notice here, the thing in the bottom, well, if I forget about the 1 and the 2, I have e to the x, and if I take its derivative, I get e to the x back. So this looks like a function underneath its derivative. So I should be thinking natural log here. So what we'll do is we'll substitute out the bottom. I'll call that u. The derivative of this is going to be the 1 goes away, the 2 stays where it is. Derivative of e to the x is just going to be e to the x, and then we multiply by dx. And then I can solve for dx in terms of du. So it's du over 2 e to the x. I substitute everything in. E to the x sticks around. Dx becomes du over 2 e to the x, and then this thing becomes a u. And you notice the e to the x's go away, and I'm left with everything in terms of u. Okay, the half comes out in front. Any derivative du over u, well, that's going to be just natural log of absolute value of u. We have a half in front, and now we can substitute back in. And as before, we notice 1 plus 2 e to the x. E to the x is always positive, so 2 times e to the x is always positive. 1 plus 2 times e to the x is always positive. So you can drop the absolute value signs if you want. Check our work. So let's take the derivative of this. That's going to give me kind of a natural log. Okay, the half sticks around in front. Natural log says take whatever's on the inside, put it in the bottom, then multiply by the derivative of the inside. Derivative of this, the 1 goes away, we carry the 2, and then derivative of e to the x is e to the x. And you notice the 2's are going to go away, and I'm left with our original integrand. So the check works.